ones that we stopped on. So we'll start the video here. And our last topic is from grade 12. That is the binomial theorem. So we have combinations in our binomial theorem. Last year you probably used the NCR a lot. A lot of textbooks also use this notation as brackets with an n on top of an r, but not as a fraction, just a number on top of another number. And then you had your formula for NCR on your formula sheet in grade 12. I always remember, so I'm going to pick random numbers, 12, choose 7. I always remember the formula because the 12 happens on the top and then the 7 happens on the bottom, and the other number on the bottom always adds up to the top number. So 7 plus 5 is 12. So 12 choose 7 will be 12 factorial over 7 factorial, 5 factorial. So 4 choose 1. Okay? I can use the formula. Some of them you can do in your head. You have 4 items. You choose one of them. How many ways could you do that? 4 ways. So sometimes we can just do things logically. 4 items, I choose 1. This is the answer to this will be 4. But we can also use our formula, which I have the 4 factorial on the top, 1 factorial, and 3 factorial. And of course, how do you simplify factorials? Do you remember that you can simplify factorials by expanding the bigger one? So if I had 10 factorial over 8 factorial, and it was non-calculator, and I had to come up that the answer was 90, I could start expanding the bigger one. Factorial means repeated multiplication all the way down to 1. But when I get to 8, I say, well, I'm just going to add the exclamation mark there because it would keep going. I have an 8 with an exclamation mark on the bottom. These will nicely simplify away. And I'm just left with 10 times 9, which is 90. Now, if you know 4 choose 1, you know 4 choose 3. Because every time I have 4 items, if I take 1 away, I'm left with a group of 3 left. So taking a group of 1 is always identical to taking a group of 3. This is easy to see when we look at the formula, because now I have 4 factorial and the bottom is 3 factorial and 1 factorial instead of 1 factorial and 3 factorial. It comes out to 4 again. Try 5, choose 2. Mental math on your own. Don't look up until you have an answer. Is that hard to do? How many of you cheated? Again, the biggest one is the 5 factorial, so I expand that one until I get to something on the bottom. Those 3 factorials cancel out. Then you just get 10. What happens if you have n items and you don't choose any of them? How many ways can you do that? One way, you don't choose any. As far as the formula goes, we get something interesting in the formula. we get a 0 factorial, which doesn't make sense according to the normal formula for factorials. The normal formula for factorials say start at your number, go down until you get to 1. But if I start at 0 and I go down, I get to -1, and then I get to -2, I will never get to +1 if I keep going down by 1. 0 factorial is its own special rule. It's always equal to 1. And so if you have n items and choose none of them, the answer is 1. There's one way to do that. Don't choose any of them. See, trying to think of a real life example of this. I have 20 players come to volleyball tryouts, but I don't want to run a volleyball team this year. So I choose none of them. There's no volleyball team. There's one way to do that. Done. That would be disastrous. I'm sure I wouldn't get into any trouble with that either. This is actually a funny story. So I'm going to say about 8 to 10 years ago, maybe not even that long. I'll say roughly about 8 years ago, all of the IB courses were getting new curriculums. When they write a new curriculum, there are textbooks companies who see dollar signs in their eyes, because with a new curriculum means they can write a new textbook, forcing all the schools across all the places in the world to buy new textbooks, making them lots of money. So when it came to the math curriculum, they looked at the math curriculum and they said, you know what, actually, the math curriculum's pretty good. We're just going to take out one unit. So basically, the curriculum is the same. So everybody's like, well, we could just use the same textbook, right? Because you haven't changed anything. And they're like, uh-oh, this isn't going to make us any money. So then in permutations, they chose to change this notation to this, which I've never seen anywhere else other than that curriculum change. I don't know, maybe it's the notation that they use in San Marino, I'm not sure. But it means the same thing. It was the only thing they changed. But if you have n items and you choose all n of them, that also is going to be one way to do that. I have 15 players come to my volleyball tryouts. I decide to keep all of them. How many different teams can I make? Just one. They all make the team. Okay. Do you remember Pascal's triangle? Where you just add up the two above it to get the number below it? And that those numbers all connect to combinations. As far as remembering how they connect to combinations, this is how I do it. I take the 5 there. I go, that is definitely 5, choose 1. And so what would come right before 5, choose 1? 5, choose 0. Then 5, choose 2, 5, choose 3, 5, choose 4, 5, choose 5. And you can pick any row and change it to combinations quickly using that little strategy. You don't have to remember the 0, choose 0, the 1, choose 0, and so on. And from this, we can get our binomial theorem. This is the long way to write out your binomial theorem. On your formula sheet, remember this formula? In grade 12 pre-calculus, it was on your formula sheet. It said that if you wanted to find a specific term, if I wanted to find here, term 1, term 2, term 3, if I wanted to find term 3, then k would be 2. and you would have n choose k. See how I have n choose 2. Then whatever a is, which in this case is, right, this was for a plus, in your text, on your formula sheet, this was for a plus b to the n. So whatever your first term was, in this case it's an x, you would have that to the n minus k. And if k was 2, it'd be n minus 2. And then your second term, b, which in our examples a, oh my goodness, these letters are terrible. Because our a is x and our a is b, oh. Okay. First term and second term. And that is going to be to the k. So we had this formula on our formula sheet in grade 12. It finds a specific term. The binomial theorem follows the following pattern. Starts with n choose 0, n choose 1, n choose 2, all the way up to n choose n. You start with your first term having all of the exponents and going down by 1 each time. Your second term starting with none of them and then going up by 1 each time. And that's the pattern for doing a binomial expansion. So use the binomial theorem to expand this. Well, we could write out the complete formula for this. And this one you could use Pascal's triangle. I'm going to color code here, these green numbers. That's just a row of my Pascal's triangle. 1, 4, 6, 4, 1. And then I started with an x to the 4 and no 1s. Technically the 1s make no difference here because you're multiplying by 1. Then x3, then x2, then x1, then no x's. So sometimes I'd take a shortcut because these combinations right here circled in green that row of Pascal's triangle. Do you remember from grade 12 that if the exponent was 4, there was going to be 5 terms, always one more than the exponent? I sometimes remember this by just doing x plus 2 in brackets squared, because that's easy to do in mental math. You see that you get 3 terms. You get 1 more when you square it. You'll get 4 terms when you cube it, and so on. So the exponent of 4 tells us there's 5 terms. I went to Pascal's triangle. I looked for which row had 5 numbers. 1, 4, 6, 4, 1. And that is these combination parts of that formula. So when we look at our second example here, again, I'm going to circle these in green. I'm going to look at my Pascal's triangle. I'm going to go to the row that has 6 terms, write it in green. And I could have written those instead. And now if I take each of those and simplify, I can multiply numbers together, right? 5 times 2, that makes 10 now. The 10 times 4 would make 40. The 10 times 8, 80, and so on. Right, and that's how you would use Pascal's triangle to figure those out.